আপনাদের এবার we are going to talk about the log4j, this recent pandemic in the Java world, and what it is and how we can resolve it. We have a friend of mine who works in the security space, Erik Coslow. He's a uh, he is from the conscious security. He's gonna tell all about this log4j vulnerability and how we're gonna sort it out, and we're gonna take a lot of question from him. We're expecting a lot of question from you as well, so feel free, who are watching live and who are over here in the audience, you can definitely ask this question the same way. I will get the question to you. We will get the mic to you, and you can definitely ask the question, and we also receive questions from the live audience as well. Hey Eric, how are you doing? Good morning, man.
Good morning and evening. I am doing acceptably well, I guess. It's no longer a major emergency for a lot of people like it was the first couple weeks.
Great. All right. So yeah, tell us a little bit about this vulnerability, how it surfaced. I mean, we've been using Log4j for like 15 years now, and nobody knows about it. And recently, we have just hit the rock bottom. I mean, how this happened?
Yeah, so basically what happened in Log4j, it's a library that everybody uses simply because we have to look at logs. Like if you want to know what your application is doing, the thing that everybody has used for years is logs, and the thing that the open telemetry people promote is logs, metrics, and tracing. So you have to have something that produces information. So we go after logs. So the gist was JDK update or Java util logger. It's okay, but it's not very good. Like the API is a little wonky and stuff doesn't really make sense. So people didn't use it. Log4j, people really liked it. Logback, people really liked it. SLF4j, why not a logging facade? Log4j2, it's a lot faster. Let's do it. So a lot of people just picked it up in order to see what's going on with their application in a totally normal way. Unfortunately, what most of us didn't realize is that it was actually parsing and interpreting statements that went through it, which is really bad.
All right. So in terms of affecting area, how worse it is. I mean, recently I have seen a lot of news, and everyone is sort of in panic. So tell us a little bit about it. You know,
Yeah, so the panic was definitely warranted. The gist is because it was remotely exploitable, like any data that came in that went to the logger and was interpreted as a string could be executed as code. So what you have is 100% unauthenticated remote code execution vulnerability. Whereas if I can get your server to log my string, I can take your server over completely. And obviously that's really bad. I've been seeing different companies get popped. I forget, there's the finance company that got hit with a $4 million ransom or something. There's a lot more of these things popping up, and it's really bad. One of the things that people are doing here is they're setting their username to log4j payloads that look like dollar curly brace RMI colon, and then the location of a class that will get the server to reach out and download it. And the reason they do this is a lot of applications will log a string that says, username failed to log in. So if I hit you with that payload and you log my failed login attempt, congratulations, you download my arbitrary code.
I mean, in Java community, we don't see this sort of impact so many for a long time, right? We think Java is relatively safe language, and uh, that's how it's been. So tell us a little bit about from the perspective of you worked in a security space. So I mean, apart from Log4j, how should we react to this, and how serious we should be in the future?
Yeah, so for context, the main application security work that I've done is I switched from software development to security with a company called Fortify that did static code analysis, looking at applications to pick out vulnerabilities in the code. Then I went to Oracle to handle the security of the Java platform in the JDK itself around the mix between JDK 7 and JDK 8. And now I'm in contrast security, and we do integrated analysis in applications to pick out their custom vulnerabilities. So the process that I kind of follow in terms of picking out where vulnerabilities are is I regard the things as like an inverted pyramid, where at the base you have the JDK. So people think, oh, the JDK, but within the JDK, you have other attributes. You have like the script engines that used to be there that had their own attack surface. You had applets that used to be there that had a much larger attack surface. Unfortunately, they're out. And you have other elements where different types of threat actors can come in, like SQL is one for SQL injection. And this is one of the reasons why you see me talk about modularity, to remove those components. And then on top of that, you have another pyramid going through that creates the libraries that make up the application. So each element here that runs at a different kind of integration point where pyramids touch is a different attack surface. So the best thing that most people can do to kind of patch their applications and work on them is to stay up to date with the security patches. Because if you patch the JDK, you've removed that entire base of security vulnerabilities that are part of the JDK that come out on a quarterly basis. Each individual library, if you patch those and you get a regular basis of patching them, you remove a lot of the risk from the individual libraries. And then the main thing to focus on is just your custom code, which now means you have a lot less to worry about.
Great, great. I want to focus a little bit on the Log4j again. You said about the patching. We Log4j has been fixed recently. We have a multiple version now. Probably it's now 2.17.1. So down the road, what's the what's the process looks like? I mean, are you gonna continue updating our source code? Our library, and deploy it frequently? What is the process? Is there any standard way so that we can without ordering a daily regular deployment on a regular basis? Is there any other ways to sort this out?
Yeah, it kind of depends on what it is in terms of how to sort these things out. So the best thing that you can do is to just get on a regular patch cadence where each time you release your software, you update the different dependencies. So what that'll do is just as CVEs come in, I've heard people talk about it as like bit decay or binary decay of those libraries that are old are more likely to become vulnerable. So you keep them up to date. Each time you release your software, just update your dependencies. There's an automated tool by GitHub that'll do this. It's called Dependabot. It'll submit automated pull requests that says you have an outdated library. It's time to update it now. So you don't really have to think about it. All you have to do is focus on your regular unit tests and integrations. That's a general good practice. The fire drill of having to go through and update a library in an emergency situation without much testing, hopefully we don't have to do that again. That has not been very fun. That's not been entertaining. I look forward to that being done.
Great, great. So let's focus on a little bit on Java space in general. As a developer, let's say I'm a junior developer. I write code, and then it goes to a code review process, and then gets deployed. How should be how as a junior developer or a software developer, I should be careful about writing secret code in general?
Oh, I was just about to share a screen, but it turns out I have to grant new permissions to this tool. Let me figure out how to do this here.
Sure. Meanwhile, I can definitely ask out to the audience over here. If you have a questions, feel free to ask questions. Raise your hand, and the audience who are watching online, please, send your questions. This session should be interactive, and based on your question, we're gonna go ahead and proceed. We'll go into answering those questions. So please, it's your opportunity to ask. He's the security guy. He's been in the community for many years, and you can ask any questions related to Java security, in general security, I guess.
If you give me just a second, I'll pop out and right back in to granted permissions, and then I can show an example of a
Sure,
code of why the
sure, go
log4j
ahead.
was missed.
Sure. If there is an issue with the mic right over here, so in case you want to ask question, just ask in our group with the hashtag JackBD. We'll pick question from there as well. Just go to your Java user group, Facebook group, and write any question about there, and just use a hashtag. I'll pick those question from there as well. So that will be easier, I assume. Right.
All right, that was at least pretty quick. Is my audio back?
Yes, I can hear you.
Nice. Sorry, guys, I don't have a ton of slides. I've been working on this stuff, so I have a bunch of different web pages and things that describe the attack, and hopefully that's a little bit better.
Sure.
Yeah, so in terms of code review, yes, it's good to do code review, but one of the reasons why things weren't caught is that the vulnerable code in terms of log4j looks like this statement right here. I'm going to try to zoom in on that a little bit. Okay, that's a little too much. But what you see here, import logging, log manager, logger, that's the typical thing. Log manager.get logger, we do that all the time. And then here is the line where they say, log.info requested API version, and then they pass the API version that comes from a header. So this looks like a totally normal innocuous statement because it is. All we're doing is we're passing information to the logger. But what the attackers do is they pass some specially crafted input to this that looks like
Erik, can you zoom a little bit?
All right. How's that? Is that better?
Let me ask the audience. Is it better? Is it better now? Okay, go ahead.
Okay, cool. Yeah, so all you're doing here is you're passing the API version that came from a remote header to the log statement. So it totally makes sense that we'd all say things like requested API version and then what the API version that people requested is. Like, this is a totally normal thing. But the problem is that the older versions of log4j before 2.7 would actually interpret that code, and they would go out and they would download your remote class files, which generally speaking, people try to have the class files pop a calculator open. And then your code would actually run it. So the vulnerability was actually taking place inside of the log4j APIs outside of your own code. So if you guys are doing code review with each other and you're looking over each other's code, like, that's certainly a great thing to do for quality. It's certainly a great thing to do for security. But what you don't really get is the interplay between libraries of how your code interacts with all the other ones, especially with the case of zero-day vulnerabilities that people don't really know to look out for.
All right, that's interesting. Based on your answer, I mean, since we do rely on a lot of open source software, a lot of open source tool, we sort of assume that open source tool is really good because it's open, everyone can see, so we shouldn't have any security vulnerabilities. But log4j, sort of disprove that idea. So, what do you think going from forward from here? Should we trust the open source, libraries that are available, or how sort of precaution should we take?
Yeah, in terms of being able to trust open source, like, the ability to trust open source is still there. Like, you get a lot of benefits when you use an open source library. The primary one being that you don't have to write whatever the functionality does. One of the differences I notice is when you go to publish a vulnerability inside a commercial vendor versus an open source vendor, it's much easier for people to publish open source vulnerabilities because they get to look for them in a variety of ways. And when you go to report a vulnerability to a company, frequently those companies will push back or sometimes they'll even threaten to sue the researchers. I have friends who they stopped reporting certain types of vulnerabilities to commercial companies because they get threatened too many times for trying to report it. So your commercial software is not really much safer. It's often that somebody either hasn't bothered to look or they haven't bothered to report. And the reason I say this is I know a number of people who have found things and said it's not worth my time to report this.
All right. So I would like to request the audience again, if you have any questions related to Java security or security in general, please feel free to ask those questions. It doesn't have to be exactly related to Log4j. Anything you can ask. Floor is yours, so it's an opportunity. Feel free to ask any sort of questions. All right. So I have a general question and regarding to Java, right? You see over here, audience, most of them are Java developers, and we write day to day. We don't even think a lot of cases about security. So do you have any sort of suggestions, advice to the developers? How should we approach these securities, and all those things?
Yeah, so the best way to handle and become kind of a security expert is to not actually become a security expert, because you shouldn't really have to. Like, you think about what goes on with performance monitoring systems. Performance is really interesting. I like doing it, but a lot of the times performance arguments and discussions tend to spiral and just go into a lot of conversations and very deep really fast. And not everyone can afford to become a performance testing expert. And oftentimes when you go to do like a hypothesis item, like from a performance engineering standpoint, you get very far away from the actual system. So what people in the performance area have done with APM, or application performance monitoring, is they just hooked up tools to watch the application and see how it performs. And by pulling a lot of metrics out of the applications, you don't need to become the world's greatest performance expert. You just need to watch what your application is doing and kind of read the signs and get it to be pretty good. So in the security space, I recommend the same approach: is hook security sensors into the application. One of these is called IASP, the other is called RASP. Kind of weird names. I think they're not as cool as APM. But anyways, what these do is they pull security sensor data out of an application so that you don't have to be the security expert. And what this does for me is I don't have to spend all my time focusing and learning on every individual framework, because I could never do that. Instead, I have the automated tool pull the information out at me, and I just look at what the application is doing, and I read the signs the same way that I do with APM. So you hook automated tools in here, and now you don't have to be the expert. You don't have to be the guy who spends all his time reading about arbitrary security vulnerabilities, most of which will never happen. You just watch what your application does, and you look at what it's doing.
Great. So since you mentioned about the tools, do you recommend any set of tools that we can use or we can try out?
Yeah, we've got a number of them. In the static analysis space, you've got tools like SonarQube is an acceptable one that some people use for quality analysis. That'll give you some custom code static analysis stuff. Find security bugs is like an offshoot of find bugs. I don't really like it, but people seem to enjoy it. Contrast, where I work, we got a tool called Community Edition that'll let you hook a security sensor IAST tool into your application that'll pull some sensor data out of it, so you can just watch it and pick out how it's vulnerable. So those are a couple of the general tools. And if you're on a more modern version like Java 11 or above, one of my favorite things to use in the open source area is JDK Mission Control. Because I hook JDK Mission Control into a flight recorder, and I extract not only performance monitoring data about how my application's doing, what its garbage collection is, but it has some level of security sensor events, because you can pick out like which classes are being deserialized, what is it that you're watching. And now that you have a lot of that data coming to you, it's part of the security sensor telemetry data that you get.
These sort of tools, in fact, works in a way that you create agents, then agents collects the information and it runs alongside your application. So there is a concern of some people that it might, it may hurt the performance of the application. Do you think that's the case statistically, or you shouldn't be concerned about that at all?
Yeah, anytime you go and extract data out of an application, there's always a question of what's the impact on performance. I was fortunate to be a part of the team that helped kind of bring mission control flight recorder into the JDK, and it came over from a different JRE called JRocket that had been under development for, I think it was like 10 to 15 years by the time that we got it, and it formed the basis for WebLogic. So WebLogic used to run on JRocket. That's where Java Flight Recorder, which is its name at the time, came from. So it's really cool to kind of inherit a product that is like new, but also has been under development for like 10 years. And man, do those guys have an eye for performance. I think its overhead at a base config was like 1.5% or something, but it was really low. So I'm not concerned about hooking Flight Recorder in there. That's a tool that I definitely don't worry about. Otherwise, on the security space, it's one of the first questions everybody asks me, which is like, what's the impact on performance? And I have this really nice image collection of like really fast cars crashed into poles or trees or things, which is from people who just wanted to go fast but didn't actually want to look where they're going. Like those poor cars, you have like a Ferrari wrapped around a pole.
That's definitely an interesting interesting example.
Oh, actually,
Because
one other example I've used is when people tell me that like performance is their only concern and like I can't implement any security controls because I have to maintain a level of performance. I try to update the release notes or recommend that they put in a statement there of like hackers can now steal records 50% faster. And usually when people realize that they're optimizing for a bad actor, they're okay taking like a single digit performance degradation to stop getting hurt.
I have another questions related to, there are a lot of companies who doesn't really upgrade their Java version per se, and the even the libraries. So do you have any suggestion for that? Like I mean, it sometimes it takes a lot of time to upgrade. It's not easy. It's costly. So do you have any suggestion for that? Like how should they approach? At least lot of security patches are getting into the newer version of Java, right? So if we upgrade them, then we are relatively safe, but it's not easy process. Do you have any sort of guideline or any recommendation? How should we approach those things?
Yeah, so you got to focus on upgrading and patching the things that you can as often as you can. Otherwise, the general thing that people do is they'll tend to virtualize things or like create wrappers around it. Log4j was really unique in that all the network wrappers didn't really function there. So what was kind of cool here, I'll share my screen again to show
Sure.
this thing in terms of what AWS did. Um, what AWS did was they produced a dynamic patch that used instrumentation to go into the JDK and dynamically patch Log4j using the instrumentation Java attach API. So it connected into the Java implementation. It looked up the Log4j class, and it stubbed out the part that would do JNDI lookups that would download the remote code. And the reason this is necessary is a lot of companies that go after things like web application firewalls, which AWS certainly has one of those. Log4j is not at a network level. You take all kinds of data that comes from a remote source and you log it. A lot of your applications, they're not web applications. Maybe you're reading a message from an MQ. Maybe you're reading from MQTT. Maybe you're taking a Kafka stream. You have all kinds of events that come into your application in WAF. They only know how to look at web. So like with regards to Log4j in terms of data that gets logged, there's just way too many sources there. So even AWS, who owns a WAF, found those network defenses to be kind of futile in this regard. Otherwise, I'm not saying don't use a web application firewall, but they're not something I really want to rely on for an accurate defense.
So there is one question over here that probably we already covered, but in case if you want to just revisit the question, this is basically what measure should I take for securing any application while writing code in general?
Yeah, so in terms of writing your custom Java code, the main thing behind a threat modeling book, and I just moved my bookshelf, so I can't go grab my copy of the threat modeling book. But the guy who wrote that, he just said, in each time that you write an application, you work on something, focus on what that has and what can go wrong with what it has. So in this regard, when you're writing a Java application, like think of the APIs that you use or the assets that you use and what those go out to reach, especially when they go to load data, because that's where the general risk is. And to me, a lot of threats come in through particular APIs, like SQL injection occurs when you use the SQL APIs. Deserialization vulnerabilities occur when you use the deserialization APIs. So what I do is I watch when people use these particular APIs, or I think I'm going to go access this particular API or these assets over here. What do I need to focus on with the threat profile of that application? How do I engage and secure that application from the particular APIs that I use? It's one of the other reasons that I recommend people who deploy an application use JLink to modularize it, because with JLink, what you do is you completely remove other unused modules. And the reason that that matters from a security perspective is if you remove a module, then it isn't possible to attack that module. So if some hacker is able to like dynamically adapt and manipulate their way around, but they need a module that you removed, their attack isn't going to work.
That's a great answer, Eric. So I want to switch a little bit gear, rather from a security perspective to in general. You have been a part of the Java community for many years. You speak, you in fact engaged with so many other communities. Like we have over here Java user group Bangladesh, and you see a lot of people over here. Do you have anything to say to this audience? Any message, importance of the community, in general?
I mean, I'm sorry I don't have a bunch of cool slides to show all the Log4j things. Normally, I try to do a lot more in terms of like a pattern presentation and have a gist of things to follow. So I'm sorry I don't have one of those today. But the main thing is like, this is an event. It was a really big event and it was really bad. And it kind of demonstrates the role of why we need to pay attention to security and kind of do some things. But we don't need people to go overkill and like start worrying about risk that isn't there. I used to talk to a lot of people who would say that everyone they knew in the security space would kind of become a little crazy and like constantly worry about things all the time to the point that they never got anything done. Keep doing things, keep writing the code, keep working on the applications that you have. Just hook security sensors into it and start producing artifacts so that when something goes wrong, you have a general idea of what it is. In the United States, there's a thing that everybody does because the president ordered it in some executive order. I forget the exact numbers, like 22 something. It's called a software bill of materials. And what it means is when you produce an application, you just inventory the libraries. The company Mac Contrast, we have a tool that can automatically do this. If you use Maven, it's Maven dependency tree or dependency : tree. Gradle, I don't recall what it is off the top of my head. I have it written down. I'm a Maven guy. But these things just produce an artifact of the dependencies that are a part of the application. And when it came time to do the crazy patch of Log4j where, oh my God, we have to all go update this right now, the commonalities that I noticed is the people who were in a relatively calm state going out about orderly patching things were the ones who had this software bill of materials because they knew where Log4j was. They knew that they had to go out and do something there. The people who are in predominantly a panic mode of like flailing around were the ones who had no idea where anything was. Sometimes they didn't know where their applications were. If they knew where their applications were, they had no idea what the libraries were. So these were the types of guys who ran around yelling about how they had to patch .NET applications, which makes no sense because they didn't have that software bill of materials. Whenever you go to release your software, do your Maven dependency tree, use a software bill of materials tool. There's a file format for it called Cyclone DX. You produce one of these things, and now when it comes time for you to be affected, you'll know. New vulnerability comes out in a library later, you know whether it impacts you or not. Because a lot of these dependencies are transitive and they're nested like 6 ways down.
Right. So at least we can confidently say Log4j isn't killing the Java. In fact, all
Yeah,
right.
in terms of
Yeah.
killing it, I wrote that article on Fujay called "Log4j Isn't Killing Java." Here it is. I'll pull it up here. Share screen window. Yeah, so I wrote this tool just to demonstrate what Log4j was doing, what the vulnerability risk is. The reason I use this term of killing Java is for like ever since the Java was released in like 1995, people have said Java is dead and there's all these prognosticators. And some of them basically, in my view, made pretty long careers for themselves saying Java is dead. Here, I'll click this link here. Yeah, this is a Forrester analyst who said, Java's a dead end back in 2010. I mean, that's definitely not true. But anyways, there are people who constantly said Java is dead, and they said it often enough that it's kind of become a joke. Even though Red Monk finally said saying Java is dead is dead, I still think it's funny to play off the death term. So I wrote this article up to just describe that, put some example payloads in here. Yeah, here's the car. That's a sample JNDI license plate there that will attack a vulnerable log4j instance. And the reason that they wrote it like this is if you have something that parses images for text, you're going to read this, you're going to write a log because of course you want to see the text that you parsed. If that goes through log4j, all of a sudden your payload is going to get compromised. So a cool, fun example of what the payloads look like, how to attack them. And otherwise, like the notice of people running around and saying Java is dead, we're going to all stop using Java. Like they've been saying that for a couple decades now.
All right. So Eric, so that's all our time we had. Thank you for your time. I mean, it's morning for you. I really appreciate for joining us over here. It's the evening over there, but you never know. We're in a sort of world where we can connect from anywhere, any places, right? Thank you again for joining us. All right.
All right. Thank you very much, guys.
Bye bye.